and stuff like that. I don't mind going first. It's up to you. I don't care. Just whatever gets decided, I can go with it.
Well, my shorts have been blowing up. I got almost 4,500 subs this month almost, and
Sweet.
4 million views.
That is
Right
a lot.
on.
Juicy.
Averaging 1 million a week.
That's huge. What have you done different?
Shorts.
Ah,
See, I had the opposite issue with granted, my channel is tiny compared to yours, but I was doing great with shorts until March 1st, and then all of a sudden, all the reach just dropped right out.
Yeah, they updated the algorithm, but I had one of mine get 600, 700,000, one get 400, like 7 get like 100,000.
that is indeed huge. And okay, we should be good to go. So what I'm going to do is I'm going to go on screen and I'm going to say, this is when I do a cold open in about 60 seconds, I'll say, hey, everybody, today we're debating evolution on trial and we are starting right now. And then this is, since it's not a yes-no question, there's no clear affirmative. Does either side have a preference on who wants to go first?
I can go first.
Cool. I'll say with the evolution side, and I'll say with Tom. I'll say Tom from the evolution side. Floor is all yours. And at that point, just like usual, you can pick up the ball and start running. And then, good, looks great. All right, here we go. First, I'm going to start the stream. Then you'll be able to see or hear us, but this is just to be sure the connection's good. 99% of the time it's good. And yeah, this will be fun. Thanks for coming on, guys. This is always fun for me. It gives me an extra spring in my step. And
hello, everyone.
It's a lot of
We've
fun,
talked a
but
lot
yeah.
on this channel.
All these people in the live chat. I just see some of these trolls. Oh man. But I like the freedom. If they want to.
Hey, just FYI, James, right now my house is relatively empty and I've got peace and quiet and the door's locked, but people are going to show up in a little while, so if I have to duck out, I will try and be back as quickly as possible.
No problem. Thanks for letting me know. And here I go. And then, yeah, I'll update the title as we go. But here we go. Thanks, guys. Here I go in 3, 2, 1. Ready, set. Here I go. Hey, everybody. Tonight we're debating evolution on trial, and we are starting right now with the evolution side's opening statement in particular. Tom, thanks for being with us. The floor is all yours.
Yeah, absolutely. So I want to share sound here. And I think this is the right video. Share. Can you guys see it?
Hello, everyone. We've talked a lot on this
Cool.
channel about how evolution is used to understand the past, but today we're going to talk about how evolution can be used to predict the future. So let's jump right in. As we've mentioned on this channel before, the hallmark of a good theory is its ability to make predictions. Anyone can make up an ad hoc rationalization to explain away data that contradicts a particular model, but not every model can be used to make accurate predictions about future data. If the evolution of all organisms from a set of common ancestors is true, then we should be able to test that. As it happens, we can. We can test it in numerous ways, with morphology, ecology, biogeography, genetics, and with fossils. So let's take some examples. Darwin himself provided numerous predictions. One of the most famous was the prediction of a pollinating insect that possessed a proboscis with an absurd length that could reach down inside the flower of a peculiar species of orchid from Madagascar that held its nectar deep inside a long tube. This insect was eventually found, a moth called xanthopan. Darwin also observed that the bones inside the wings of birds looked like they were fingers that got fused together. So he predicted that a fossil of an ancient bird with separate fingers would be found one day. This ended up being Archaeopteryx. The first specimen was discovered just 2 years after the publication of Darwin's book on the origin of species. But the evolutionary predictions didn't end there. An example of a modern prediction of evolution is one we have discussed at length, the chromosome 2 fusion, including all its details such as the telomeric repeats at the fusion site, 2 centromeres, one of which is deactivated, as well as the conserved synchrony between chromosome 2 and the 2 that remain separate in the other great apes, which can only be predicted based on common descent. Not only was the fusion predicted, but creationists have been completely unable to refute it. But since we already made a video about that, we're going to leave it there. The prevalence of mutations in organisms even allows researchers to make predictions about their prevalence in populations. For example, there are different types of mutations, such as mutations from guanine to thymine or from cytosine to adenine, etc. These mutations occur at different rates in the human population, so are found at different frequencies. Using these frequencies, we can generate a graph like this, showing the signature of mutations. If mutations were also the cause of interspecies genetic differences, then we would predict a similar spectrum graph when counting up the different types of nucleotide differences between humans and chimps. And we do. In fact, the spectrum also matches when you look at the differences between humans and more distantly related apes like gorillas and orangutans, and matches when comparing differences between those other apes such as chimps and gorillas. This makes no sense under a non-evolutionary model. Under creationism, it implies that a creator created interspecies DNA differences that just so happen to look exactly as though they had occurred by the same natural processes that give rise to within-species differences. It also makes no sense under a non-evolutionary model why genetic sequences for homologous proteins converge the further you go back in time, which was, by the way, also predicted under evolution. When we reconstruct ancestral sequences from different groups of species, we find that those ancestral sequences are more similar to one another than the descendant species, implying a branching pattern of divergence that fits the evolutionary model of common descent perfectly. Researchers also sometimes make predictions about specific genetic homologies in organisms. Michael Coates wrote the 2003 The Evolution of Paired Fins, when he specifically notes the homologies between scapulocoracoid or pectoral fin cartilage and certain branchial or gill arch cartilage. His abstract ends with this, quote, "No transformation of arch to girdle is necessarily implied, but some signal of developmental relatedness is predicted," close quote. And sure enough, the 2009 paper, Shared Developmental Mechanisms, Pattern the Vertebrate Gill Arch and Paired Fin Skeletons by Gillis, Dawn, and Shubin, found, quote, "The molecular patterning of chondrichthyan branchial rays, gill rays, and reveal profound developmental similarities between gill rays and vertebrate appendages," close quote. Another example of a very precise prediction concerns our yolk, or rather lack thereof. As all amniotes, our embryonic development is typified by the formation of several membranes, among them the amnion, hence the name. These membranes retain the moisture for the embryo, which allowed amniotes to invade dry land. Most amniotes lay eggs that contains a massive yolk sac filled with nutrients, which allowed for the development to be more complete before birth, without the need for a post-birth metamorphosis stage, as is the case with amphibians. Egg-laying is the ancestral reproductive state of amniotes, and there are still a few mammals around that do this, like the monotremes. However, eutherian mammals like us have a placenta that made the yolk sac obsolete, but curiously we still have a vestigial yolk sac that doesn't have any yolk in it. All of this points to the conclusion that our ancestors once laid eggs containing a yolk sac filled with yolk. And yolk is mostly protein coated by genes, so if eutherians are descended from amniotes that once laid eggs with yolk, we should expect to see leftovers of these genes in our genome, and we do. They are broken, but they are still there, and when compared to their functional homologs in other amniotes, they also have the same neighboring genes. This is called shared synteny, which is also a predicted phenomenon as a direct consequence of common descent. Aside from genetic predictions, evolution also makes fossil predictions. First, Robert Broom predicted the existence of an amniote with a double-hinged jaw joint based on the idea that mammals evolved from the colloquially called reptiles. The jaw joint of ancestral amniotes is formed by the articulation between the articular and quadrate bones, while that of mammals is between the dentary and squamosal. Broom deduced that the only plausible way for this transition to have happened is that, at one point, both jaw joints were together at the same time, and this was discovered decades later in Probane ignathus and a whole host of other near mammal fossils. William Deeb predicted that birds should have gone through a stage in their evolution where they had asymmetrical flight feathers on their front and back legs. He predicted this by the fact that Archaeopteryx had sparse flight feathers on its hind legs, which weren't enough to be useful for flight, so he thought they were vestigial, indicating that an ancestral stage with bigger feathers on the hindland existed. This was found in the form of Microraptor. Also in relation to birds, a feather morphotype was predicted by embryological data and later found in dinosaurs, such as Bipiosaurus. Paleontologists predicted an ant fossil that had features of wasps in the Cretaceous, and that was confirmed as Sphygomyrma. Neil Shubin and colleagues predicted a fish-like tetrapod or tetrapod-like fish, and at that stage would there be much difference, in Devonian strata of Canada, and that was confirmed as Tiktaalik. Researchers long predicted the existence of sauropods in the Triassic, and that was confirmed as Isanosaurus from Thailand. Recently, a semi-aquatic whale ancestor was found named Paragocetus. This cetacean has a flattened tail like a beaver, which was useful for propelling it through the water. It also showed how the earliest marine whales migrated from their place of origin near India to the Americas. Later whales, such as Basilosaurus, had tail flukes, while earlier whales, such as Pakicetus, had thinner tails that would not have been especially useful for swimming. Paragocetus fits in directly between these with a tail shape predicted by researchers. The list goes on, but the point is that there's no reason for these predictions to have been fulfilled if different clades of organisms were created separately from each other, as imagined both in the flood geology and intelligent design models. Then there's biogeography. Geologists have worked out that the crust of the Earth has changed much throughout its history, and organisms have had to adapt to it. Regarding this, researchers correctly predicted that fossil marsupials would be found specifically in Eocene strata in Antarctica, since they moved from South America to Australia at a time when these land masses were connected by Antarctica. The same is true for many dinosaurs and plants predicted for even earlier times based on what was alive in the then adjacent land masses of the Mesozoic. So what does all of this mean? It means that evolution works. It makes accurate, specific predictions about what should be found both in the fossil record and our own genomes. To quote young Earth creationist Todd Wood, quote, "Evolution is not a theory in crisis. It is not teetering on the verge of collapse. It has not failed as a scientific explanation. There is evidence for evolution, gobs and gobs of it," close quote. Or to quote young Earth creationist Kurt Wise, quote,
Thank you very much. We will kick it over to Ember as well. Thanks very much, Ember. First timer, we're glad to have you here. The floor is all yours.
All right, let me find that screen share button and we will do the thing. Boo, boo, boo. Oh, I have to actually open the files first, don't I? Okay, open the file. This is the fun of being a first timer, folks. Oh, where is it?
If you're listening out there right now, I want to say, folks, as you're waiting, if it's your first time at Modern Day Debate, we are a neutral channel hosting debates on science, religion, and politics. I'm your host, James. We hope you feel welcome no matter what walk of life you are from. And we'll kick it back over to Ember for his opening.
All right. Is that showing up, folks?
Yep.
Cool. Okay. Now I need to be over here so I can control my buttons. Okay, so 6 minutes. Let's do this. Is evolution science? So first, what is science? Science definitions vary. For tonight's purposes, let's say science is not about being right. It's about building models that make it possible for us to understand reality, that make useful, accurate predictions. Evolution could be replaced tomorrow or in 100 years by a model that does better, like relativity has been. We've got Einstein's relativity replaced Newton's, which replaced Galileo's. That's our evolution of ideas, if you will. For evolution itself, definition, Simple definition for tonight's purposes: a change in the heritable traits of a population over time. I included a couple of Darwin's moths there. We may get into the significance of them throughout the course of the night, maybe not, but they're pretty anyway. There are vast quantities of data supporting evolution. For one thing, we can see the changes in the heritable traits of a bull terrier over the last 100 years. For another example, we've got wild mustard, which through the selection of traits, we humans have turned into cabbage and Brussels sprouts and broccoli and cauliflower and all kinds of wonderful things. We've got carcinization. That's that principle, everything turns into crabs. That's one example of convergent evolution. Just like birds and insects and bats all developed wings. Same thing with the body shape of the dolphin, which is reflected in the ichthyosaur and the shark. These are all examples of how evolution keeps moving towards the same structures for optimal use in a given environment, because it's environmental selection pressure that drives it. There's testable, observable predictions. We have used evolution to select for traits to get more from our agriculture. We get 2.5 times more milk from our dairy cows than we did 50 years ago. We get 2 times more corn per acre than we did 70 years ago. We predicted and then unfortunately observed antibiotic resistant bacteria. And then, of course, there's the famous wall lizards of the Mediterranean, where biologists took 5 breeding pairs of the wall lizards from the island where they lived and ate insects to another island that did not have those insects. And as a result, many years later, they came back and found out those descendants have adapted and become vegetarians. Other sciences depend on evolution, just to name a few: biochemistry, paleontology, genetics, anthropology, medical research, and more. And one of my favorite proofs about evolution is humans. We know that we have not always existed. Therefore, we started to exist at some point. The crazy thing is that everybody already believes in evolution. Creationists, like in TJump's video, creationists have to accept that evolution exists. It's necessary to get from the kinds presented on Noah's Ark to the biological diversity we see today. The main complaint is the time scale, not the fact that it happens. Even science deniers have to admit that evolution can be and has been observed. Here's a few examples. Here's a single cellular organism developing into a multicellular organism in a lab. The next one over is a E. coli bacteria that developed the ability to digest citrate. There's so much in favor of it. It's crazy. So the challenge today is not to show the flaws in the model. Of course, there are flaws. There are always going to be anomalous pieces of data in any system. The challenge today is to demonstrate a better, more accurate model. And that is the end of that.
Thank you very much for that opening statement. We are going to kick it over to the, you could say, skeptical side of evolution. But before we do, I want to mention, folks, if you have been living in a cave on Mars with your fingers in your ears and you didn't know about our upcoming in-person conference on Saturday, April 22nd, you can see this at the bottom right of your screen. DebateCon 3.1 is Modern Day Debate's own debate conference. It's going to be in Fort Worth, Texas. If you have not already, check out the links in the description box. We've got a link for in-person tickets, as well as a link to watch all the debates live that day from home. If you're too far from Fort Worth, Texas, you don't want to miss this conference. Life moves fast, folks. So you might want to take a look around, because this conference, you don't want to miss it. Go for it. Check out the links in the description. And with that, we're going to kick it over to our creation side. Thanks very much, Jen and T-Rock. The floor is all yours.
In your choice, whether you want to go first or you want me to.
You go. Take it away, T-Rock.
Okay, I'm going to give a quick introduction for myself. I represent the young Earth creation side, and yes, it's a globe. I am not an evolution skeptic. I outright deny that it's a valid model altogether. So I'm not borderline anything. The data is pretty clear to me, very clear. So with that, I'm gonna start with the nature of the fossil record, just because it happens to be some of the material that I had prepped, and it's pretty good. I don't think I'm going to share my screen or do a whole lot as far as that goes. I'm going to kind of talk my way through it a little bit, and if we wanted to look at some of the information, that's fine. The fossil record. So that's one of the big supporting arguments for evolution. It's a completely bogus argument to use it to support evolution, and the reason there are several reasons for that, but probably the most outstanding to me is there is zero apparent geological deep time in the fossil record, like absolutely zero. So sediments are laid down very rapidly by water transport, and the vast majority of the fossil record is directly tied to some sort of water transport. In between those, occasionally you'll get something like igneous rock that comes through, and of course radiometric dating applies to most igneous rock, and no apparent geological time either there, because everybody knows that volcano eruptions are by definition catastrophic and quick. So you get an outpour of igneous material that sometimes gets interstitched between sedimentary layers, and you want to do a radiometric dating test on it of some sort. The problem is there are no such thing as volcanoes that have volcanoes that people have witnessed to erupt that have accurate radiometric dates pinned to them. None. So the counter argument is typically something like, well, you have to use the correct dating method, and young volcanoes don't fit in that. And that's a very poor argument to say the very best you can about it, because if a young igneous formation does not reset the clock on radiometric isotope ratios, then there's basically no way to argue that older ones that nobody's seen somehow mysteriously had that ability. So the absence of apparent geological time is a huge factor in looking at the fossil record. Another really big important factor to look at is that if you take an example like the coelacanth, I think the first coelacanth that was discovered was pinned with a date of something like 300 million years. It was assumed for a very long time that coelacanth went extinct. Okay, fast forward, I don't know, a couple of decades, I think, but somebody discovered live coelacanth fish off the coast of Africa somewhere. What does that tell you? Absence from the fossil record is zero indication of extinction. It means absolutely nothing. So when you try to make predictions about extinction from the fossil record, it's doomed to failure, because eventually what happened was another coelacanth was found, and I believe it was pinned at a date of somewhere around 60 million years. So you had a 240 million year hiatus, and guess what? The one that was found at 60 million years was just as recognizable as the one that was dated to 300 million years, which was just as recognizable as the live version found off the coast of Africa. In other words, extreme stasis is yet another problem for trying to predict extinction in the fossil record. So without the ability to predict extinction in the fossil record, and combining that with the fact that just about everything you find is fully formed and has and a lot of it has a very close or almost identical modern counterpart to it, you can't use the fossil record to predict arrival either. So it fails on both points in a very serious way. On top of that, most of the time studies that you do, they all have some sort of interdependency built into them, and so people like to talk a lot about what's the word I'm looking for? The error bars. They like to talk about the error bars and how they pin you down to a pretty tight precision. That's a fallacious argument just because it completely misrepresents how the science is actually done. Those error bars are typically derived directly from statistical analysis of how accurate your direct measurements are. In the case of radiometric dating, that would be like let's say mass spectrometer counting of individual atoms. And so it's a very accurate way to count atoms. So the precision is very high on it. The problem is there is a completely separate metric you have to do on the age assessment itself. And so one example I'd like to give is like in carbon-14 dating. You can measure atoms as accurately as you want to all day long, but once you get outside of observable human history, you have to have something to gauge its accuracy by. So if you go out and start counting atoms of carbon-14 in diamonds or coal or dinosaur soft tissue or something like that, you can find significant levels that are above the so-called background radiation or whatever. And then you just say, okay, well, the atom count was wrong. The age is what really counts. And then so you reference a completely different system to basically correct the error bars in the age assessment itself. So in a nutshell, those are some of my major arguments against the validity of evolution and how it approaches the science. So I'm gonna relinquish there and let Jen take over.
Thanks, T-Rock. I guess the first thing I need to do is share my screen to my PowerPoint. Is that working?
Yep.
So can they just see my PowerPoint?
I can crop it.
No, it's all good. I just want, no, it's all good. I just want to make sure. Hi, I'm Jen. Nice to see everyone. Thanks to everyone for joining the debate. I'm sort of hard to give a summary of why I feel like I'm in a good position to talk about this, but I'm really into science and theology. I've been studying physics for quite a long time, worked in signal processing for 7 years and learned a lot about how information works and how systems evolve in general. So I'm not really here to debate against the premise of evolution, and I'm not really sure what creation means. I'm certainly not trying to say that I'm taking a position against conservation laws, because I do like to think of myself as highly scientific, but there's problems. I mean, clearly, if you've had a look at what's out there in terms of what's being said, it's at the very least leaves something to be desired. So I'm hoping to share my critiques with evolution as it's currently understood, as well as briefly show what an alternate model could look like that wasn't based almost entirely on fallacious presuppositions. So we'll get right into it. Assumption 1, the idea that information travels along genes. Now that may seem so totally self-evident, but actually there's something that is causing the matter to have the structure that it does. And so the matter itself and its structure are always the effect, never the cause. And so whenever I see a theory where something is causing other things and it's a material cause, I'm suspicious, because I know that the only possible coherent model is mind first. And that's really where we get into where I differ. I'm not questioning the record. I'm just saying this model's not telling you what you think it does. And in a lot of ways, there's no way to verify, because I'm sure the other interlocutors can validate that DNA is not something you can really test. Genetic information is not something you can really get your hands on in anything other than a statistical average for stuff dating back to the point that you'd need to date it back to actually be certain about evolution, to actually look at the theory and say, you know what? We're in an impossibility of the contrary situation here, rather than this, which is, frankly, I feel more confused when I look at this stuff than before. Before I had some basic, intuition about grass and flowers and things kind of making sense and structure and symmetry. But then I read this evolution stuff and it just seems like linear presuppositional gibberish. But anyway, assumption 2, genetic variation is heritable. That seems so right, doesn't it? But it's actually not how it works, because the mind is the decider. So where the actual first domino gets pushed is when you remember your parents based on shared traits and reincarnate into a fetus based on how similar you are. And that's not happening on the level of the genes, that's happening on the level of the soul. So even though you can say, well, there's tons of genetic similarities between people in the same family. Well, sure. But that's basically saying, well, I can't really say anything more about you. I can't differentiate you from your siblings. So this theory isn't really not nailing down a whole lot of precision. So is genetic variation heritable? Actually, not quite. I have darker eyes than both my parents. Oh, well, we got to now invoke some magical thinking. What's that? Oh, it was a recessive trait. We can save the day. And then when everything isn't determined by genetics, guess how we save the day? Epigenetics. So just really invoking magical terms at every turn. That's telling me it sounds more like theological gibberish and not so much a scientific theory, which is a really simple model or structure that you can put some information in, get some information out that's different, that tells you something about something that hasn't happened yet, aka a prediction, just in case anyone forgot. And this is really the most problematic assumption, I think. The idea that mutation that is caused from random things is what is going to lead to these changes in animals and plants and living organisms. These claims like this are completely unverifiable because a term like randomness is completely undefined. Assumption 4. Natural selection acts on genetic variation present in a population, favoring individuals with advantageous traits. More circular logic. We have fitness, therefore fitness. Scientific model would actually mean you were giving criteria defining fitness, specific criteria, specific enough criteria that you could go out and test it.
Got about a minute left.
Oh dear, I had so much more, but I got so excited, I guess. So we'll just skip ahead. You know, I'm sure we can get into it. No evidence whatsoever for this mysterious RNA to DNA transition that is supposedly part of the evolutionary theory issues. It's, yeah, again, I think I mentioned it was imprecise. I want to get into this more because one of the other interlocutors mentioned brassica. So I think that is an important example to show how macroevolution cannot be anything in the same ballpark as microevolution because of the rate at which it happens. So I'll just skip that for now. And yeah, I think I mentioned random mutation earlier. That's not a thing. So there is an alternate theory. You have to embrace a different type of metaphysics, which are actually parsimonious. And then, you know, so there's a bit of a learning curve. So I won't go into it now, but I did have some other stuff to share, but I think I might just skip it because James told me I had a minute, what feels like a minute ago. So we'll just hopefully be able to explore some of these ideas in greater depth with the open conversation. Thanks again for having me. I'll wrap it up here.
Thank you very much for that opening. And we are going to jump into the open dialogue. Just a couple of quick things in terms of formatting, folks. We will have Q&A following the open dialogue. So if you happen to have a question, you can tag me in the live chat by using @ModernDayDebate. Otherwise, super chats go to the top of the list. And as I had mentioned earlier, we are thrilled about this conference coming up that you can see at the bottom right of your screen. One of the big debates there, if you didn't know about it, is going to be RN Raw and TJump. It's going to be huge, folks. We're thrilled about it. You don't want to miss it. Check out the links in the description for the conference coming up in just 8 days. It's coming quick, folks. With that, thank you very much, folks. The floor is all yours. And I'm just going to rearrange the pictures on screen. So in case name tags don't match up, folks, I will fix that.
All right.
Forgot to remind you guys, if you guys turn off your camera, it'll scramble the pictures on me. But ready for you.
Okay. Jen, I'll start with you because you just went. You confused me a little bit here. You said that matter is never the cause, mind first. Are you implying that, like, flowers and grasses and whatnot have to decide to be flowers and grasses before they become flowers and grasses?
Well, that implies a mind is a deciding agent, and there's only one mind. So that's why it's a bit hard to understand where I'm coming from sometimes, because I'm using parsimonious metaphysics that are top down. So one mind, we don't assume it's possible to ever establish that there is even such a thing as one mind, but we consider it useful fiction. And therefore we say, yeah, we'll model it with one mind. And then do the modifications relative to that universal mind, which is what I had a diagram, but I didn't really get into it. The funny little plump mushroom sort of looking sort of apple thing.
Oh, with the
I can
twisty
share it
tube in
again.
the middle. Okay, yeah, I gotcha. So you're going with a single mind, universal mind, something along those lines, and then every mind is like a fragment of that kind of thing.
Matter is a fork of, it's like a tuning fork that becomes attracted to the order of the mind. So it's, you think of a simplistic metaphor as when you have those tiny little filings and they're put in a proximity of a magnet and they take on a structure.
Okay,
You know what I mean?
I think I've
How
got the
there's like
shape of
the
it.
little,
How
there's just the filings and then the magnet comes and then they come up. It's kind of like that. The matter is being polarized or ordered by the mind.
Alrighty. How does one verify a model like that? Like, how do you know that?
Well, that kind of comes down to opening the door about a conversation about what is most important in science, because we haven't really had that conversation yet. Like we're sort of saying science has to be everything. You know, we got this crazy TJump intro video. It's like it's like maybe trying to be all things to all people or something. But we would have to have a conversation and say, you know what, the most important thing about science, let's just say, is the ability to make predictions.
Sure. And can this universal mind model make predictions that we can test?
Yeah, but then it's a description. And so there's a question about differentiating a description from a prediction. And so the predictions would be things like aggregate. On the aggregate scale, the thermodynamic efficiency will always increase.
Okay. Well, I'm going to stew on that for a minute. T-Rock, I want to bring you in here. I understand you are not a fan of deep time, which is why I tailored my presentation specifically to deal with stuff we can observe in the present. But why, with the coelacanth, were you suggesting that it went extinct and then was recreated or something along those lines?
No, that's quite the opposite of what I said. What I said was fossils appear suddenly, quote unquote, suddenly. They're just there, and the coelacanth it's a good example, because when you see the very first so-called first coelacanth, it's quite easily identifiable as a fish. It's just a fish. As far as I'm aware, it's a scaled fish at that. So scales fully formed, fins fully formed. It's a fish. Nobody's going to mistake it for something else. So there it is, fully formed. First time you see it, 300 million alleged years ago, and then basically you have this hiatus in the fossil record for the evolutionary estimated time of about 240 million years. That's where the 60 million year line comes from. Now, the deal, though, is that 60 million year discovery didn't come for decades after the original. What came before that 60 million year discovery was the live version. So when people saw it, they were like, wait a minute, this was extinct 300 million years ago. And quite obviously it wasn't. So what you have an example of is extreme stasis. And that's just one of many examples. My slides here, if you want me to show them real quick, James, I'm going to share my screen because I didn't really do this earlier.
We don't need them. We're fine. No.
Okay, so Just some quick examples here of what stasis looks like. So here's 3 or 4 examples right here. Take a look at the leaf, living and fossil from some alleged 20 million years ago. In my world, I used to do tree trimming, and I still do some. Did some this week actually. That's a maple leaf, and it's called liquid amber, but it's basically just a maple leaf. Is it a different species from what I'm used to? Probably, but irrelevant because it's easily recognizable as a maple leaf. So anyway, in response to your question, Ember, no, I'm not saying they disappeared, got recreated, and reappeared again. I'm saying there is zero deep geological time evident between the one that's supposed to be 300 million years old and the ones that live today. What makes much more sense is they never went extinct in the first place. They didn't evolve in the first place. They started out as coelacanths, and they're still coelacanths.
Okay, I see what you mean. Yeah, we've got there's a few different examples of creatures who haven't significantly evolved over long periods of time, like crocodiles and alligators.
How about these? Turtles, shrimp, more fish, amber.
Sure.
There's a
However,
lot of them.
there's also
spiders.
made
I
that
think
we don't-
TJump's video showed a I don't remember what it was, but there's spiders, insects, worms, snakes, you name it.
Yeah, all kinds of things. Earthworms have been largely unchanged for millions of years as well. There are certain optimal configurations, as we've seen with modern living creatures experiencing convergent evolution. Like the shape of a wing, the function of a wing is virtually the same from critter to critter to critter. You've got different variations on the design, like a dragonfly has 4 wings instead of just 2, but the aerodynamics are the aerodynamics, so wings develop into wings. Also, it's worth noting that we don't yet have every fossil. Like, the Earth is huge. We have a percentage of fossils. We don't even have enough fossils to tell what percentage of fossils we have. So just because we haven't found a coelacanth within that large window of time doesn't mean there isn't one. It's sort of a black swan kind of thing, if you see what I mean.
Well, that's what I was saying. You can't predict extinction by the fossil record.
But
you
nobody
can't
does that.
predict arrival either.
Nobody does that. It's not a thing. It's not like we can predict. No one's trying to predict extinctions by the fossil record. That's not a thing. So I don't know why you think that's significant. Like, obviously,
I'll give you a real quick rundown of why. And maybe the word predict isn't technically the correct thing, but essentially that's what they're trying. It's a postdiction, really. But the reason I say that is because the classic is the KT boundary with the so-called iridium boundary, where dinosaurs went extinct specifically because of that event. But it's the same basic problems with the coelacanth.
Dinosaurs didn't go extinct. Nobody's predicting all dinosaurs went extinct. Birds are dinosaurs. Crocodiles are dinosaurs. Sharks are dinosaurs. There's lots of things that are dinosaurs that still exist. No one's trying to predict things going extinct by the fossil record. It's just not a thing that science does. Obviously, if you have a fossil of one thing, it could still exist today. There could be a T-Rex hiding in some kind of forest that we just haven't discovered yet. That's possible.
Right.
No one cares. It's irrelevant to evolution. It's irrelevant. What is relevant is the ability to make predictions about the future of things that we actually are trying to predict, like EVR patterns in DNA, like double hinged jaw joints that we're going to find a transition between a lizard and a mammal, like a Tiktaalik, a transition between a fish and a lizard, Archaeopteryx from dinosaurs to birds. These are predictions we've made that have been correct. These are real evidence. So you guys have a hypothesis, a nice thing that makes you feel good in your imagination.
Predictions are for things that haven't happened yet, not descriptions of things that have already happened.
So, Jen, if I predict I'm going to find a gold brick in my backyard, that's a prediction. And if I find a gold brick, that is a confirmed prediction. So if I predict we're going to find a double hinged jaw joint evolution between
right, but let's go a little further back from that and look at the assumptions. But we're still at the part of understanding the assumptions.
Hold up, Jen, let me finish.
I don't disagree with you on the out. You don't need to explain to me the same thing for the 50th time.
Let's give Tom a quick
I want to know
chance
how
to
you
finish.
can justify your
John, I
presumption.
do want to give
Go ahead.
Tom
Tell me
a
your
chance to
presumption
finish.
laden stuff, Tom.
John, I do have to give Tom a chance to
Okay.
finish, and then I promise to come over to you.
So the ability to predict things we don't know yet, like a double hinged jaw joint, transition between lizards and mammals and getting it right before we knew it, that's evidence. That's real evidence. You guys don't have any evidence. You have an imaginary story that makes you feel good. But what we need is some way to differentiate which of these hypotheses is better. And the way to do that is the one that can make the correct predictions the most. Evolution makes tens of thousands of these. Now, Jen wants to bring up about your assumptions. How, assumptions are irrelevant. You can make any assumptions.
Well, I was trying to tell you that predictions are about the future, Tom. So if
Yes.
evolution was actually a model, it would tell us what we were going to evolve into.
No.
Not, oh, well, okay, I'm going to go and find some stuff and just put it in my tree diagram and then it's going to make sense. So the issue is, what's the basis for the assumption that the way things look is dictated by their genetics?
Well, those seem like two different questions. First is no, evolution does not need to predict what we're going to evolve into. Evolution says that we're going to evolve into what is a,
If it
whatever is
were a
the-
theory,
Shush,
Tom, it
shush,
would be
shush,
predicting the
shush,
future.
shush.
Let's give Tom another 30 seconds and we'll come over to you, Jen.
So no, you do not need to predict what we're going to evolve into. Evolution is saying we will evolve into things that are more conducive to the environment, whatever the environment is. Do we know what the environment's going to be? No, because environments change based off of geology and other things. So no, you don't need to predict what we're going to be. Predictions apply to any unknown facts about the universe. Can you predict that those will be known prior to us actually discovering them? It applies to anything in the past too. You don't need to predict what we're going to evolve into. Literally irrelevant.
So geology is not a science either, I guess.
It is.
But seriously, I just want to know where you get the assumption that the way a species looks has anything to do with its genetics.
Well, that's not an assumption. That's literally like
It
phylogenetics.
is an assumption, I'm afraid, of evolutionary theory.
No, we can literally change the genetics and then watch the species form, and it has a different shape.
This is your same argument as we can cut out someone's brain and therefore consciousness comes from the brain.
Well, that's
It's the same argument as that. It doesn't actually justify it's just, you're just circularly reasserting your presumption. I'm asking, forgive me, if you're going to use an axiom,
causation.
if in my system, if you're going to make something an axiom, it has to actually be empirically verifiable. Like anytime
It
you
is.
want, it's got to be so obvious as to be borderline self-evident if there can be such a thing. And this does not really seem that way because it can actually, be falsified.
Let me say something real quick about this whole prediction conversation. I've got a slightly different perspective than Jen does, but I definitely appreciate what she's saying because she's absolutely correct, and you're not predicting anything. What you're doing is using inductive or deductive reasoning to basically follow a pattern. That's what you're doing. Okay, but here's the deal: when you start citing prediction as the thing that validates your model.
Yep.
Evolution falls really, really flat on this. And the reason I say that is because when you're going to make a quote unquote prediction in the colloquial sense, if you're going to make a prediction based on your model, and say that it distinguishes your model above another one, you have to use the principles that are exclusive to your model.
no, you don't.
Cannot use the overlap area. And so, citing things like you have no evidence, there's huge evidence. You have to micromanage your definition of evidence to say otherwise. There's a giant fossil record out there buried in marine.
Go back to the first thing you
transport.
said. Go back to the first thing you said, that you need to make predictions that are specific to your model. That's wrong. Like, no, that's completely wrong. Like, no one is. You literally can't do
That's
that.
not what I
supposed to-
said.
Wait,
That's not what I said.
what did you say?
What I said was, if you want your model to bear the status of standing above another model, you have to get out of the overlap zone, and you have to use the principles that are exclusive to your
Yeah,
model.
that's wrong. That just shows you don't understand science or philosophy.
No,
You
that shows you don't
no,
understand
Stop,
difference
stop,
between-
Stop. One sec.
No,
Let me
you
give the
stop for a
arguments.
second.
I
You
need
talked
to
for quite a
actually-
while a
I
little
need to
while
give
ago.
the argument there. So you don't understand basic philosophy here. It's called the problem of underdetermination. There is no ever being able to get over to like exclusive facts that are only in your model. There's always infinitely many empirically equivalent theories that can explain all of the data, no matter what. We could all have been created by leprechauns farting out the universe 5 seconds ago, and that could create all of the evidence we see in front of us. So the fact that you want to have some exclusionary fact that only works for one hypothesis is just an ignorance of basic philosophy. You can't do that. Doesn't matter. No one wants that. What we want is the ability to take whatever your hypothesis is, no matter how ridiculous, and use it to predict things we don't know yet and get it right. That's evidence. It doesn't matter if it's exclusionary, because you can't get that. You literally can't get that.
Okay, so you might have that as your backdrop philosophy. It's not mine. It's not logical, and it's logically inconsistent. And I'll go a big step further and say it's actually self-defeating. If there are infinitely number of viable hypotheses, then all you're saying is nobody can be right, and we can't really know. That is just it's obviously self-defeating.
Wait. So tell me about the leprechaun. So leprechauns could have farted out the universe 5 seconds ago and made everything how it looks today. Why would that not explain all the data?
Because that is pure fantasy.
You don't need to invoke leprechauns. It's about necessary conditions, not whatever crap I can think
This is
of.
a specific question. Why would, suppose there are magical leprechauns, they farted out the universe 5 seconds ago to exactly the way it looks to us today, including our brain states with all of our memories and all of the empirical data we see, why would that not explain all of the data? Everything we see. Literally everything.
Because it has a positive formation energy?
That doesn't make sense, Jen.
How much energy would it take to make farting leprechauns big enough to make the universe?
I don't know.
Take a lot of energy. The universe minimizes energy. Your argument is invalid.
No, it's not invalid. Arguments can't be invalid, Jen, in that sense. Invalid means the conclusion doesn't follow from the premises.
It's called a joke, TJump. But let's move on.
Let's not move on.
Given the problem of underdetermination.
Let's not move on. So T-Rock made a claim that you need predictions that are exclusionary to your hypothesis, which is just dumb. Like, you literally can't do that. And I gave you a proof to why you can't do that. Here is a ridiculous hypothesis I came up with, one of the infinitely many that there are. Leprechauns farted out the universe 5 seconds ago with all the data we see.
Actually, you literally can.
What?
And it has happened.
Can what?
Oh, okay. Well, I mean, if you have a model with exclusive information, we would be excited to hear about it.
Well, let's go to that in a second, but let's say whatever your predictions are, I can say leprechauns farted out the universe with that fact, and it wouldn't be exclusionary to yours.
And then I can say, show me your peer-reviewed paper, since that's your standard.
What does that have to do with your original claim that you need predictions exclusionary to your model? I just proved that claim false. You don't need that.
No, you didn't. You dreamt up a fantasy story and said it proved the claim false. Okay, I'm going to demonstrate in real time how the difference in actual predictions play out between evolution and the young Earth creation model. One of the popular predictions is, for example, Tiktaalik, right?
Tiktaalik, yeah.
Tiktaalik. Somebody said, oh, look, we can predict there should be a fossil with this general morphology found in this layer of rock strata, blah, blah, blah. Okay. And you called that a successful prediction of evolution, and you said creation has no evidence and cannot make predictions.
Wait, what?
Which is complete baloney. So what actually happens with Tiktaalik is you're in the overlap zone. Any farmer knows that there are animals all over the planet that live in the water, on the land, in the mud, in between the water and the land, underneath the rocks next to the mud. All over the planet, there are forms that have mechanical locomotion ability to transit these areas. So if I'm going to look for something that looks like a salamander, I'm going to go to the mud to find it. I don't need a backdrop of any origin story. I can just look at modern biology and kind of figure that out. So more of the overlap zone that exists between evolution and creation is that there's a general sense to the creationist as well as the evolutionist that most of what you see in the fossil record tends to fall in these patterns of ecological zonation. And hence the quote unquote successful prediction of Tiktaalik. So now, again, you don't need a backdrop in origins at all. You just need to go look at some modern biology and figure out what environments possess which types of morphology.
Well, I want to use that as an example. You can do that. So let's use Tiktaalik as an example. Tiktaalik is in the overlap zone of the magical farting leprechauns, because the magical farting leprechauns could have farted out a fossil that looks like Tiktaalik in their universe. So you didn't provide any predictions that are in the overlap zone of between creationism and magic farting leprechauns. So you haven't provided any unique predictions at all. So I don't know why you think this is relevant. anybody, what you're doing is exactly what I did with the farting leprechaun hypothesis. You take a fact that we discover that somebody else predicted, and you say, well, I can explain that into my worldview. This is called post hoc rationalization. So you can take any fact you want and fit it into your already preconceived worldview. And anybody can do this because we have these things called imagination. Now, we don't really care about that. And science doesn't care about that. It's fine that you can post hoc rationalize anything facts you want into your worldview. It's not evidence of anything. There is no overlap zone. Everything is an overlap zone. And so it's not a relevant argument. What we need is, can you predict it before we know it? And guess who did that? Evolutionists.
So if everything's an overlap, then basically what you said is creation does have evidence.
No.
Yeah.
No.
You literally, in one sentence, said that creation has no evidence, and then you said everything's an overlap zone.
No. So let me try to help you out here. So yes, everything is in the overlap zone, which means any hypothesis can post hoc rationalize any data we have. Does that mean that data is evidence of any hypothesis? No, because the evidence is the ability to predict things before we know them and get it right. So the only thing that counts as evidence.
Okay, Tom.
Wait.
Thank you for the help, but I don't need it. Let me use and to be honest with you, I was hoping for people who wanted to talk about the actual science, not some bogus philosophical view of the science. I wanted to talk about science, the actual biology, the geophysics, the chemistry, whatever. You guys don't want to talk about that. You want to talk
maybe
about
we
the
could go into
philosophy
like
about
whether Tom or Ember think that the fact that there's no model for abiogenesis is an issue.
There are lots of models. I don't know why that would be an issue, but I do want to finish.
They don't say where the cell comes from.
Abiogenesis is irrelevant to evolution.
True.
Well, that's a claim that I can't see how it could be possibly be justified. So do you not see any issues with a claim like that?
Hold on, real quick before we go down that. That's a pretty big shift, and I don't mind that. But let me finish where I was going with the prediction real quick, and then we can shift gears. I used the Tiktaalik as the example of the successful evolutionary prediction in creation. Prediction, understanding that truly what Jen said is true. We're not telling the future. We're basically giving a descriptive rendition of what we should find, and so in that sense, it's not technically a prediction, as Jen said. But
it's not a
working example for
prediction.
The working example for creation is where Dr. Russell Humphreys basically here on Earth, before satellite missions got sent out into deep space, put together a mathematical physics model based on standard physics. And he said, okay, it looks to me like the planets were formed from bodies of water. And so what he did was he again, very standard physics, water molecules possess, or hydrogen molecules, I think is more specific, but they possess a very super weak magnetic field. And if they're aligned perfectly, you get a strong magnetic field. And when you flip them all of a sudden and disorient them, you can induce a magnetic field into something else. So anyway, he basically took the mass of the Earth as water, as I understand it, and used that to use standard physics calculations to say, okay, the planet Uranus should have XYZ level of magnetic field strength today. And now he put a model together. You can go find this on the internet quite easily, I think. But go fast forward a decade or so later, a shuttle actually got sent out into deep space like that, and lo and behold, they measured the magnetic field strength of Uranus and some other bodies, and Dr. Russell Humphreys' model was based on specifically a 6,000-year timeline using standard physics. So when they got out there and they measured it, he was off by, I think he says, a factor of 3. But the same evolutionary deep time model was off literally by about 6 orders of magnitude. And again, time is the relevant factor there. So
okay, that is this dude.
And that is the exclusionary principle that separates the difference between evolution and creation. Deep time is one of those exclusionary principles.
Actually, no. So like magical farting leprechauns could fully explain that as well. So it's not exclusionary. You don't understand philosophy. But I do want to mention a couple things here. One, Robert Humphreys was wrong. We know he's wrong because we can use his calculations to calculate the magnetic field of all different bodies. And he only got one right. The rest of them are all wrong, which is called luck. You
Sorry,
luckily get
correct,
those right.
exactly incorrect misinformation.
No, that's exactly correct. Like if we try
He
to use
applied the
his
same.
equation,
He applied the same model to several planetary
and they're all
bodies,
wrong.
and
No,
they
no,
were
we can
all way
take
closer than the evolutionary prediction said they should be.
Evolution
they're-
doesn't predict geophysics in
It's true.
astronomical
Also true.
bodies.
Wrong again. Sorry,
What?
that's just
Really?
completely inconsistent with the literature.
Evolution has to do with biology. It has nothing to say about the magnetic field strength of freaking Jupiter.
Okay, but you have to have the deep time for your evolutionary story to work.
Well, actually, you don't. That's completely irrelevant. Like we know that's a factor in reality. Deep time is a thing. Do you need that logically? No, you don't. This is an irrelevant thing
Hey,
to keep bringing
Tom,
up.
I've got a question. How old is civilization?
I don't know, 50,000 years.
Oh, okay. So not 6,000 years.
No, that was definitely
Definitely not.
because
So someone, if they thought that, they'd probably be on par with a young Earth creationist in
Yes.
terms of their logic then? Oh,
there'd
cool.
probably
Just wanted to get a
literally
quick
be
confirmation.
one. Yes.
I
Like yeah,
don't know if we want to go into the abiogenesis thing, or if people want to like maybe concede that I have a point that
what?
it might be problematic that there's no model for abiogenesis.
There is a model. What are you talking about? Like even if there wasn't a model, that wouldn't be problematic. It'd just be an argument from ignorance fallacy. But there is a model. So two things: one, it wouldn't matter if there's no model. Two, we have a model.
Which is?
RNA world hypothesis.
Okay. And did you know that they've tried to replicate RNA-based life and they've failed every time?
It's no one's tried to do that. So no one is trying to create.
Well, they certainly have.
But you can
Tried
come
to
up
make
with a
RNA
model and not
replicators.
try and test it, and it's still a valid model.
Yeah,
Sure.
it would be irrelevant even if that were true, because humans' ability to replicate something doesn't make it true or false.
But verification, you'd agree, is part of the scientific method.
You don't
It
need-
literally
if we
sounds to me
tried
like
it-
you both just said that evolution is unfalsifiable.
No.
not from a totally unrelated question that hasn't even been seriously investigated. If we investigate something that is related to evolution and it comes up wanting, then yes, there would necessarily have to be some changes made. But from where we sit right now, we really need an entirely different model to come in and do head-to-head combat with evolution and do a better job of describing reality. And so far, I'm not seeing one. I'm just seeing a couple nitpicks about the magnetic field strength of Uranus and the lack of proof for abiogenesis.
Well, so I did want to address the stuff a little bit. So whether we humans, as Ember said, have been able to reproduce the entire sequence of events from RNA to life is irrelevant. It makes no difference whether or not we can do the entire series of events. There's about 100,000 steps to go from RNA on clay forming corpuscles to get any kind of cellular reproductive self-organizing life. No, we don't have that. You're right. We haven't done that. Do we need that? No. Have we made
We
predictions?
don't need the model to make verifiable predictions?
You don't need to predict literally every single step from beginning to end of the model to be able to have a confirmed model. No, all you need is to accurately predict certain steps. If you can predict some of the steps and get it right, that's evidence of your model. If a different
So how do we know when the model is acceptable if we don't need to get it 100% right?
If it accurately predicts the future a significant number of times, that's good. That's all you need. And the more times it predicts it, the more reliable it is.
Real quick, can I ask Jen, what is your education level, if you don't mind?
I have a honors degree in physics math.
Okay, I'm just curious because I personally don't have any academic achievements anybody's going to care about. I just heard you saying that you worked in in physics basically, right? So just to give you a quick background.
It was more
for
in
me.
Technology.
Sure.
Not applied physics. Yeah, more with
Okay.
computers. But go ahead.
Okay, fair enough. But you're used to handling a lot of mathematical models, I would assume.
No.
Yeah, I had to
I'm
come
gonna
up with
no
some.
on that one. I'm gonna vote no. I vote no. Onions, no. The mind onion, no.
Yeah,
but
no. The only reason I ask is because my educational and career background is along the lines of mechanical engineering and manufacturing. So, I it's not the same as what you do. I may not have the accolades that you do academically, but I do an application version of what I do, and mathematical models is a big part of engineering. So, whenever I look at evolutionary mathematical models, they're a joke because you can't use that type of logic in the real world to actually build buildings and bridges and cars and stuff like that.
That's
We're
literally
not building
irrelevant.
bridges with evolution. It would be really cool if we could grow a bridge or something. That would be
No,
amazing.
you're missing my point. You want to talk evolution as in biology? That's fine. We can do that because that's the whole deal is evolution on trial, and I know that means biological evolution. That's fine, but it also relies heavily on mathematical models
No, it doesn't. Like Darwin did zero math. Darwin did zero math. And he was right. He was right in all of his book. He did no math. There was no mathematical equations in the origin of species. Didn't happen.
Okay.
You don't need math.
You could just so far what I've heard is you don't have to test your hypotheses.
Well, you
don't have to have a mathematical model. You can
don't
just
need
look at the evidence, make a deduction, and say you're right.
No, prediction. If you can make novel predictions and be right before we know them, that's the standard that we need to show that you are correct. Mathematical models don't matter. They're right. There are mathematical models in evolution. They're all right. And we can use them to build bridges. Actually, that's been done. But you don't need to. Like, none of that's relevant. You're bringing up these irrelevant criticisms that are just outside of your ability to comprehend things and saying you can't comprehend this really complicated thing, therefore it's false.
Like, one possible prediction could be that fitness is going to increase over time. And then I'm going to put it to you and say, like, well, how do we define that? It doesn't have to be a perfect definition, just even a partial definition that we can actually test. It's got to be specific enough to test.
Wait, are you saying that's
to the exclusion of other interpretations?
Are you saying
how about antibiotic resistant bacteria? We predicted that if we continue to misuse antibiotics, that bacteria would develop resistance to it. And lo and behold, here we are in a world full of antibiotic resistant bacteria. They gained fitness and became more immune to our
that's a great
Go ahead. Sorry.
It's a great point you bring up, Ember, but here's the huge glaring problem with it. So you predict antibiotic resistance in bacteria, but in my line of work, we do a lot of root cause analysis, and in root cause analysis, you're literally advised to ask like 11 questions deep to sort out why are the bacteria resistant to any antibiotics. And as it turns out, what's really happening is in some cases anyway, the bacteria has the ability to absorb the antibiotic drug that you give them, and there's always a small percentage that absorption method that the bacteria uses is basically dysfunctional. It can't absorb the antibiotic into its interior inside the cell wall. So do they become antibiotic resistant? Sure, but all you did was killed off the ones that could absorb it and left behind only the ones that were already broken and couldn't.
Congratulations, that's fitness. You just proved evolution.
Yeah, that whether it's natural
selection
or artificial
described genetic
selection.
entropy and de-evolution.
Can I just say something real quick? The antibiotic resistance doesn't actually establish that, because, like with the example that T-Rock gave, if you kill 100%, you have 100, organisms, you kill 99% of them. Sorry, I said that wrong. But let's say you kill 99% of what you have on your hands from the hand wash, and you get 1% left. That eventually reproduces to cover your hand again with 100% of what was originally there, meaning it's more resistant because it wasn't killed in the first shot. That didn't actually trigger any evolution. There's no change there. The only thing that's changed is the distribution of the things that were already there in the first place. So I'll agree. I mean, that's totally perfectly fine logic, and it makes total sense. But you haven't established any link to genetics, or that actually any changes happen with regards to the.
You described the change. It's resistant. That is a change. It is a change in the heritable characteristics of that population.
Yeah, but the population had that trait before the 99% were killed.
Jen,
the
population
1% didn't die
means the majority.
because they happened to not die because they were resistant to it intrinsically. They didn't gain a resistance by putting the cream on your hands that's antibacterial.
Well, and
go ahead.
Sorry, to put a finer point on it, what's actually happening is there is a serious loss of fitness in the resistant bacteria, because this has been done before. If you turn them back into the wild, so to speak, they can't survive. They needed what the original population had that you killed in the wild. They only survive when you coddle them in a petri dish and give them the antibiotic that killed all the healthy ones.
No, it's
To
done.
an
So
extent.
no increase in fitness, a serious decrease in fitness, and nothing that
It's
suggests
an increase
it's
in
going
fitness
to
for
it's
that
going, the
specific
populations are going to
circumstance.
continue to evolve into the next great thing.
Well, literally, you're just denying reality because we've done this experiment. Like Ember mentioned the experiment where I forget what it was. The bacteria had developed the ability to process citrate. That new ability is a developed thing where the entire other population died because they didn't have any food, and they didn't require them. They no longer needed this other population that had these other magical deteriorating things that they lost. All bullshit. Didn't happen. Worked just
Sorry.
fine.
Factually wrong again.
No, I just proved you wrong. So in the
No, you
citrate
didn't.
dish,
You just made a random bunch of statements that weren't true.
So there's a petri dish. You add citrus, which is a food source. You take away the other food source, they're going to starve to death. The ones that can't process citrate starve to death and die. The ones that can survive, and they thrive, continue to grow just fine. And they don't, and all that other stuff you said about the older population, you need those traits to survive. All bullshit. They didn't need it at all. So it's just wrong.
You haven't established any genetic drift. You've just established a drift in the distribution of the population. So I'm trying to entice you to go a little further and question the assumption that what is motivating the change is biological
material. I'll tell you what actually happened with those populations is they did have the ability to digest citrates, but they don't normally do it. So they have a regulatory gene that allows it to switch back and forth. It is normally switched off. Nevertheless, there's always a remnant in the population that have it switched on. And so by feeding it the citrate, you kill off the ones that have it switched off and leave only the ones that had it switched on in the first place. They already had the ability to digest the citrate before you conducted the experiment. And all you did was killed off the ones that.
No, that's right.
And again, it's the same thing. The fitness decreases because as soon as you return them back to a wild state, they're not nearly as fit anymore.
Well, it's a trade-off, T-Rock. Like for example, sickle cell anemia. It is a decrease in fitness in most circumstances, but people with sickle cell anemia also have a hugely heightened resistance to malaria. So if you're in a malaria-rich area, it's actually a huge fitness advantage.
So fitness is based on the environment. So if you have an environment and a specific organism is fit for that environment and you put it into a different environment, obviously it's going to be less fit for a different environment. But guess what? That's not relevant. Literally irrelevant. Fitness is, does an organism function in an environment better than a different environment? So there's no trade-off. There's no like more or less fit. It's all bullshit. It's based on its ability to survive in an environment. And so if you make it able to survive in one environment, like an environment with citrate and not other food sources, obviously if you put it into a different environment with different food sources, it's not fit for that environment. Literally just basic understanding of fitness here. Come on, T-Rock, come on.
Just want to clarify something. There's a lot of people in the audience saying, well, that is evolution, Jen. No, that's artificial selection. Okay, you take some of that antibacterial stuff, put it on your hands, that you are artificially selecting against, 99% of the bacteria on your hands, which then presumably might come back, to haunt you down the line. But that's not evolution. That's artificial selection. So another problem I wanted to bring up is that artificial selection, like brassica stuff.
It's also evolution.
It happens at a really fast rate. Like we can actually observe it happening, through agriculture and stuff. Whereas if you look at the time span, the age of the planet, like I'm not a young Earth creationist. I accept the radioactive or radiometric data on the age of the planet. And that hasn't been that rate of change in the species, artificial selection happens very quickly.
So does natural selection. There are cases of natural selection where it happens just as quickly.
Well, the fossil record might not agree due to something called punctuated equilibrium.
Punctuated equilibrium is literally it happening at fast increments. It's the graduation is the one that you're thinking of. So yes, it does happen very quickly in natural.
Punctuated equilibrium is it doesn't change for a long time, then boom, almost like a quantum state transition hint, and then it stays the same for a long time, and then boom, it changes again. That's punctuated equilibrium, and that's what the fossil record reflects.
In some cases,
to me, that's very different than something that we can witness happening. So it couldn't possibly be the same process because the scale of time in which it happens is so radically different.
Jen,
Well, yeah, and so
in punctuated equilibrium, the changes happen over a very short period of time. Like there's no change for a long time, and then there's a lot of change very quickly that you can see happen. So punctuated equilibrium would be an example of like artificial selection for a single population or something. Those would be equivalently fast. Like your argument is
so there's a huge equivocation fallacy there, because the examples you guys give of what you call evolution, again, you're living in the overlap zone and you're describing
no such thing.
something deteriorating, and there is nothing about that suggests the scale is going to turn into a feather. There's nothing about that suggests the bellows lung of a reptile is going to turn into an avian lung of a bird. Not one single shred of that indicates that.
All the predictions indicate that. We can predict things in the future. You can't. Our ability to predict things in the future and get it right is evidence of our entire hypothesis, all of those things. So your inability to predict anything, and you can only post hoc things we've discovered and try and fit it into your worldview, is evidence your worldview is garbage and ours is right. Only the hypothesis that can predict the future before we know it and get it right is the one that is justified.
So you want another very successful creation prediction that was based on a 6,000 year timeline?
Well, you haven't given one. Like I've debunked the one you gave before.
Why? By saying it was lucky? That's not a debunk.
No, it's debunked because we can use his model to calculate the predicted electromagnetic strength of every single planet, and it's wrong pretty much every single time. It is wrong at an equivalent rate to that of, or it's right at an equivalent rate to that of random chance. You just random number generated.
Is readily available on the internet. Yes, anybody can look it up and find out that you are completely factually incorrect.
Go ahead, do it yourself. Go ahead, do the electromagnetic calculations for any planet other than the ones that he got right, and you'll find he's wrong on all of them. Because guess what? Planets aren't made of water. Water doesn't equate to an electromagnetic field. His mechanisms are just wrong. Do you know what does accurately predict those? Geology and cosmology. They accurately predict the magnetic fields of every single planet. Your guy doesn't. It's false.
Got just a few minutes before we go into the Q&A. Any concluding thoughts?
Potato.
I'm still waiting to hear anything resembling an alternative model or even a single prediction.
We'll jump into the Q&A. Go ahead, T-Rock.
Sorry, I was just going to say you obviously don't accept predictions. You just you guys are just throwing some denial out there and calling it a debunk. Again, go look on the internet. Dr. Russell Humphreys.
I'm familiar with Dr. Humphreys.
Here's two more.
He's wrong.
He's a physicist.
A prediction. The reason we're rejecting this, like you brought up why we're rejecting the prediction. That's true, because predictions have to be specific and correct at a higher rate than chance. Like I can predict the lottery numbers, and if I predict the lottery numbers for all time, I get one of them right. That's not a successful prediction that confirms my hypothesis. That's a lucky guess. Hinduism predicted the age of the Earth is 4.3 billion years old. That's a really good, accurate number, but it was a lucky guess. All their other predictions are wrong. You can guess a lucky number correctly at a rate equivalent to chance, and that's not evidence of your hypothesis. You have to be able to predict things at a higher rate than chance. And guess what? Evolution does that.
Tom, you ever produce your own mathematical model of anything?
Yes.
Like what?
I write programs.
You write a program.
Yes.
Does it require intelligent input?
Sure. Yes.
Does it require your math to be correct?
Hopefully.
Yeah, I'm describing literally standard physics models using standard physics math, and you're just basically hand waving and saying it was a lucky guess. Everybody's wrong. Blah blah blah. That's not
so
how
a mathematical model that gets
or science either one work.
So a mathematical model that gets 99% of the answers wrong and one right is a failed model. We don't accept those. So I don't get what's missing here.
Let me give you another quick example of where a successful mathematical model based on a very short time frame made a successful prediction in your terminology, and that is where the helium retention in zircons was discovered via a prediction that they should be there based on 6,000 years of elapsed time. Nobody thought they should be there. all the models said, no, it can't be there, blah, blah, blah. Too much time's passed. Helium slips out between the lattice structures of crystals too easily. And lo and behold, there was the predicted amount in those crystals based on a standard physics model with a 6,000 time constraint.
So I would need to know the methodology of why you think that the helium is in the zirconium, and I need to apply that to other physical to other particles to see if the same model that we use to make this prediction is accurately describes the other things. And guess what? I would bet you $1 billion right now it's going to get it wrong 99% of the time and get a lucky
And your
guess.
mathematical model that you just spewed is guaranteed to be incorrect.
Well, you know what, T-Rock? I'm not familiar with any of that stuff you just said, but I'm willing to concede it. You win on that point because it makes absolutely no difference to evolution.
So evolution, the standard model of evolution doesn't require deep time. Is that what you're saying?
The standard model of evolution has absolutely nothing to do with finding heliums and zircons.
But does it, the whole point is the time constraint that evolution has to operate in.
Your prediction about helium and zircon does not prove there's no deep time. It's irrelevant. It's irrelevant.
Any closing thoughts, Jen?
It was an interesting debate, and I appreciate having a chance to bring up my points. And thanks everyone for being here, especially James, the host, as well as the audience members who had important contributions to make.
Yeah, thank you, James. I know this one was really, really difficult to put together. We all appreciate you sticking with things. Audience, you should absolutely give James a like on this one because it was hard.
Thank you for that support. Really do appreciate it. And we definitely appreciate your support, folks. So please do hit that like button if you haven't. In terms of quick housekeeping stuff, folks, if you did not know, Modern Day Debate is on podcast. You can find all of our guest links. So Jen's, T-Rock's, TJump's, and Ember's links, both in the description box here on YouTube. And if you're listening via podcast, as all of these debates end up on the podcast within 24 hours, so you can find us on Spotify, Apple Podcasts, you name it. You can also find our guest links in the description box there. Just want to let you know that. And we're going to jump into it with these questions. We're going to move as fast as we can. If you guys can do me a favor, just so we can get through as many questions as possible for the audience, if you're able to keep the rebuttals to a minimum, that way we'll be able to get through as many questions as possible. Malavia says, congrats, T-Rock, on demonstrating that you horribly misunderstood science. And Jen, you want to argue that the quote, the mind is the decider and that the soul is real, yet you have a problem with presup. We'll give you each a chance to respond to that if you'd like.
Am I going first or?
Help
Sure.
yourself.
Well, okay, I'm not sure what to say to that exactly. Yeah, sure. Presuppositions are necessary, perhaps, to build a certain level of complexity or structure to an argument. That does not mean we always have to use the same ones, or that we shouldn't inquire as into the nature of the presuppositions themselves. In fact, it's the most important thing in philosophy, in my opinion. So thanks for the question.
You got it. T-Rock, are you going to let him say that?
They can say whatever they want. TJump did a pretty good job of just throwing claims out there like that, and I'm back where I was with TJump on this. You know, that's much more of a philosophical argument and just an empty claim than it is show me the hard science. Not one single evolutionist has shown me any hard science yet. What they've done is made some descriptive claims without a proper root cause analysis, and then said, "Oh, we don't have to have a mathematical model." What is science without your mathematical model? I've got a mathematical model on my screen right now of magnetic field decay in the Earth. So
the problem is you don't understand why it's evidence. People need to explain to you the philosophy, because that's the part where you're not understanding. So you understand why it's evidence. Right now, you're incapable.
So you're making Jen's point for you have to have a philosophical underpinning of your science before it's worth anything. Thank you, Tim.
Literally. Science is a offshoot of philosophy. Of course, you need philosophy to build science, obviously.
This one from Matthew Smyser. Am I saying it right, Matthew? Let me know. It says, Jen fan. You got a fan out there, Jen. So such a bright future. She has to wear shades. Says for Ember and TJump, do we or how do we understand and or test the direction of change adaptation in larger life forms?
Direction. So again, fitness is just the ability to survive within an environment. So as the environment changes, the organism changes to the environment. So there's the example of the lizards who had eyesight, went into a black cave where there's no light, and then they lost the ability to see because their eyes no longer did anything. And so it's not about, there's no direction to it. It's just whatever happens to work best in the environment. That's the direction. And we see this all the time in different species who move into new environments and either gain or lose functions in order to accommodate the new environment.
Yeah, it's harder to chart change in larger species because of the longer lifespans, longer gestational periods. With bacterian labs, we have a fairly easy time. We can, churn out generations every day and then keep a running log, which many labs do. With larger life forms, the best we can do is just keep an eye on them and keep a log and see what happens.
You got this one coming in from, do appreciate it. J3 Loviator, J3 Womber says, it's on now. Thank you for your hype. Karen B says, we do not live on a model. Do not try to base reality on a model.
I completely agree. A model is designed to help us understand, but we should never, ever confuse the model for the real world it's trying to describe.
Of course, we should base reality off models. Models are literally our imagination trying to describe reality. And if they can accurately predict the future, that means the model most likely describes reality. Yes, that's what we do.
Yeah, that's more that self-defeating philosophy that was exemplified early on in the initial presentations, where we don't want to marry ourselves to a model because it might change. In other words, we can't really know. We might be right today, but tomorrow we might prove ourselves wrong. That's self-defeating philosophy.
It's not self-defeating, it's progress. Learn what the words mean.
I screwed this one up earlier. Jen, Matthew Smeisher also wanted to hear your response to what Ember and Tom said regarding how we understand or treat the direction of change or adaptation in larger life forms. If you can remember back to it, what would your response be? If you can't remember back to it, just let me know and we'll give them a chance to give a quick summary of what they said.
Well, I think the question was about how evolution theory would answer that. So I'm kind of being skeptical towards evolution theories. I don't want to confuse anyone. I mean, if they're asking about my model, then there's a primordial mind and the matter accumulates over time, becoming more thermodynamically efficient in separating the mouth from the anus, technically. So the spine is what's going to be doing that gradually. So we would expect not necessarily a longer spine over time, but a greater degree of deviation, okay? Because the deviation from the primordial state is what gives you it's like with a Hooke's law, whatever that is, a spring. It's like the more it's compressed, the more power comes back. So in order to accommodate corporeally all the additional thermodynamic efficiency, that evolution definitely is the direction we're going towards, or however you say that, would be that there would be more pressure basically on the spine or spinal region over time. And that pressure is pushing away from the natural configuration of undeviated mouth to anus separation, which is, as I said, grows over time. So that would be a prediction of my model. At least I don't know how the other people are doing. Hopefully that answers it. Sorry if that's unclear.
It's pressure.
Juicy, to
Pushing
say the
down
least.
on me.
This one coming in from Dingley Bumbus says 3 cheers for James, TJump, and Ember and Jen. Ember is new to me. TJump, James, Ember, and T-Rock. Sorry, T-Rock. T-Rock, are you there?
I'm here.
T-Rock is T-Jump's father. So that's why they're both T-Rock and T-Jump.
I am James's father.
This one coming in from Matthew Smeisher says, mind versus chemical process. Particle had to go from a non-sentient molecule into something that decides it is hungry or wants to survive. Evolution explained this without invoking consciousness. And then, Jen, please follow up.
I'm sorry. Is that a question?
Oh, they just want to hear your response to Tom and Ember's initial answer to this question.
Why do you think
Yeah, I'm
consciousness
sorry.
is fundamental? That's the question.
The question is, why do I think consciousness is fundamental?
Yeah.
Well, they're
to-
asking,
Because-
they want a follow up from you, Jen. They're asking for both Ember and or Tom, and then they want to hear your response to that, Jen.
So they have to go first.
The
Yes.
question,
Oh, sorry.
they was a little convoluted. The question is, how do we get from a single molecule to something that wants to eat and survive?
Roughly speaking, yeah, that's pretty good.
And our answer is probably materialism, evolution. Then the matter combines to bury brains. Brains have intentions, etc. And then Jen's position is no, its mind was first, right? That's your position, Jen. So how do you explain this process?
Jen, thoughts?
All right. Well, I was going to share the screen and just show my image from before.
The onion tree?
Well, I don't know if it's quite an onion, but the apple mushroom there. So yeah, I'm really sorry. I need you to ask the question again. I'm confused.
No problem.
They're saying life came about from matter, and you want me to respond to why that is nonsensical?
The question is consciousness came from matter, which was not conscious in our worldview. Electrons not conscious. They come together, build bigger animals, which then become conscious. Your version is the opposite of that, right? Why?
Yeah, okay, because logically, there's no way to tell any boundary between consciousness and non-consciousness. And the easiest example of that is we assimilate non-living matter all the time. So there's no easy way to tell between living and non-living. And consciousness is not something you can draw a boundary between it and anything else. And in my philosophy, we try to minimize boundaries because we understand that boundaries cost energy and that energy is minimized. So what you're looking at here is a boundary, which is also not a boundary. So it's like a superpositional boundary, non-boundary, and it represents the realm of possibility, which is everything except 3 + 1 simultaneous observations. And so this shape, number one is your undeviated mouth to rectum, as I mentioned earlier, separation. And then you can see how this shape number 2 is like a simplified version of number 1. And then from 3 on is how that shape deviates from, through evolution, matter accumulating in a body enables a deviation from the primordial mind, which then increases its efficiency, which you can approximate it as the amount of torque that is separating the mouth from the anus. Because if you look at something like a single cell, it doesn't have a mouth, it doesn't have an anus. So those two things are delocalized within its body. And so the force of life is a localization of a separation between a mouth and anus. So maybe there's a metaphor in there about, getting your head out of your ass or something. I'm not sure, but thanks for listening. Hopefully that clears it up. I'm sorry it's hard to go into quickly. And yeah, panpsychism for the win.
Thank you for that. This one coming in from Hates Stairs says, T-Rock, how do you explain the heat problem with young Earth creationist perspective?
There is no heat problem. It's and I will grant, I will readily grant that in the creation circles they consider a heat problem. However, you're asking my opinion. I actually am very interested in geophysics and geophysical processes, and so the reason, functionally speaking, the reason there is no heat problem is because the accelerated decay that was proposed through the discovery of helium in zircons that shouldn't be there in a deep time setting. So it was assumed by the creation model that was the product of accelerated decay. Okay. The reason there's no apparent heat problem anyway is because that rock that it was found in is associated directly with creation week, not the flood week. And during the creation of the earth, it was formed in water and out of water. You can't have a heat problem for an unspecified volume of water where there's no life forms on it yet. So there is no heat problem, but more specifically, my model that does deviate from accelerated decay is that it could just as easily be quote unquote accelerated fusion. And fusion is an energy consuming process. So what is apparent in the rock that was in question here, it's granite, not rhyolite. So it's only gone through a single significant heating cycle. But where was I going with that? In that it's has only undergone one heat cycle, and so because it's associated with creation week specifically, accelerated cooling is also relevant, apparent in that exact same rock. So you've got radio halos from polonium and some other signatures of supposed radioactive decay. Nevertheless, it absolutely demonstrates some super fast cooling mechanism that's apparent there too, because you can't capture polonium halos like that, except the rock cools very quick. And the reason is because it'll anneal the signature completely out of the rock if it stays hot for very long. So no heat problem. It could be fusion instead of decay.
Matthew Smelser says perform genetic algorithms for work and require initial fitness as well as statistical probability input coefficients. So I think they're saying they perform genetic algorithms for work and require initial fitness as well as statistical probability input coefficients, still ends in a forced result. I don't know what that means.
I'm not sure what they're trying to say there.
You got it. This one from Matthew Smelser says, did the unicorn, Tiktaalik, or the leprechaun fart first, and why? Rainbows. Great debate. James, more Jen, please. Jen, wow. You're a fan out there, Jen. Any thoughts on this rainbow question, Tom?
I didn't hear a question mark.
Next up, Jake Nelson says, it was more of a troll question. Says, so a population has a mutation that makes them not die, that becomes the dominant phenotype. How is that not evolution?
That's for Jen.
Jen, are you with us?
It's really hard because, like, can you repeat the question? I thought you were addressing it to someone else.
Or T-Rock, if you want to. They had said, so a population has a mutation that makes them not die. That becomes the dominant phenotype. How is that not evolution?
It's about the hand washing thing. Like if you put soap on your hands, there's a mutation in one of the bacteria that causes it to survive. It's about that question.
Okay, so yeah, so how is that not evolution? Again, that's an equivocation fallacy on what you mean by evolution. No creationist argues the fact that things change. Most biological entities are a super high percentage of water or liquid of some sort, and so liquid by its very nature is constantly moving and has to change. It's not textbook evolution, because it does zero to establish that feathers come from scales, or I mean name your morphological feature that you think was derived from something else. It does nothing to establish any of that. It's basically an example of genetic entropy. And genetic entropy is usually discussed almost exclusively in biological terms, but it's an actual quantitative study of molecular disassociation, and biological units are not immune to that.
And was
this one coming in
false.
from, do appreciate it. Bitter Truth says, to the creationists, why are there birth defects? Is this because you're punishing infants? Do you does your creation model like evolution does? Let's go with the first part. Why
I
are there
assume that
birth
one is for me.
defects on creationist perspective?
Yeah, because matter is imperfect. Matter's just an appearance of the mind. So it's an approximation or simulation. So there's going to be imperfections. And there's also evolution competition. So when bad things happen to one animal or one life form, maybe good things happen to another. So it's not to be understood as a punishment, because that would imply some type of an intention operating on the universal level, and that is something that's premise we negate. Thanks for the question.
So the creation perspective on that real quick is that that is very much a theological question, not a science question. Why is there death and suffering in the world if it was created and designed to be very good? It's a theological question. If you can't handle the raw science itself, you can't handle the theology at all. Most evolutionists or Bible critics can't even get the basic details of the flood account correct, and it's like 3 chapters at most, super quick, easy reading, and they still can't get that correct. So they're not going to get the theology correct. But there's death and suffering in the world because it started out as a very good world. People did something wrong, and the consequence is that things fall apart when you do something wrong. Don't believe me? Go set up a lab experiment in a purely secular environment and do your experiment wrong and see what falls apart with it.
All according to plan, by the way. The perfect plan from the perfect being.
Who drowned babies.
So you guys are theologists now?
Yes.
No, thank you.
I think that I'd say it's fair to say you addressed this, though it wasn't direct because I hadn't read the question. But Bitter Truth said they wanted it corrected. They said that their question was asking whether or not birth defects are punishments from God per se. And it sounds like you're saying that I think we've heard your answer to that in the broader sense. This one coming in from Justin says, Jen, do you believe you and T-Rock have the same number of ribs or not? Do you believe you have genetic mutations and differences from your parents?
Well, the first one, the ribs, I mean, probably. And the form of your question is presupposing the truth of your assumption here. So you're saying, well, mutated from your parents. It's like, well, if I'm going to grant that a mixture of my parents is derived from mutation, I'm not even sure that that's what evolution is actually saying. So I think it's important to clarify. I'm not disagreeing on the evidence. I'm saying maybe there's a better way to understand this stuff that is more in line with what's actually going on.
You got it. This one from Bitter Truth strikes again, says, let's debate religion versus evolution and see which one makes more sense by evidence. Why every single organism has 4 nucleotides. Both sides reply, please, and thank you.
What was the question?
Why does every single organism have 4 nucleotides?
Magic. It's a magical farting leprechaun just farted them out exactly as this way. It's perfectly consistent with all facts, and there's no like exclusionary data you can show to disprove that. So it's magical farting leprechauns. That's why.
I have to admit, I have no idea why there are 4. Why not 6? Why not 20? Don't know.
Gotcha.
I'm not sure, but I'm sure if we studied it in greater depth, we would find there was a connection to the dimensional limit of the universe, which is 3 + 1. But it can also come out as 7 and 14, depending on what angle you're looking at from. So it's more complicated than just, everything's 4. But thanks for listening.
You got it.
So real quick, this is basically what I categorize as a homologies argument. You can look at skeletal formations and make homology arguments. You can look at DNA and make the similar DNA argument, which is just a variation on homologies. And this nucleotide argument is the same. It's a homology argument. The reason everything has that much commonality is because of the food source. If we did not have that commonality, amongst all living creatures, our food source would not be viable for every living creature on the planet. The food source is plants, by the way, plants. So plants are created on day 3 before the animal life forms are and before people are formed, because you have to have a food source for your living organisms. And in order for a worm, a bear, a deer, myself, a chimp, doesn't matter, in order for us to eat vegetation, we have to share molecular similarities to be able to digest it, process it, get the the growth, the metabolism, the cellular repair, everything we need from it. It ties to the food source and what the food source is made of.
You got it. This one coming in from, do appreciate your question. Bitter truth strikes yet again. Say T-Rock, so God is punishing infants via genetic disorders.
Okay, again, I'm just, it never ceases to amaze me that evolutionists want to appeal to their version of theology or some kind of bizarre, vain philosophy when they can't stand with the hard science. But philosophically, no, it's not a punishment. What I was describing a while ago was a consequence, not a punishment. If you put the wrong fuel in your car, for example, there's a consequence. It's not a punishment. It's what happens when you do it wrong. Don't put water in your gas tank. Put gasoline in your gas tank so you can avoid the consequence, not the punishment.
You got it. This one from Mark Reed says after show on Mark Reed's channel. Mark, if you shoot me an email, I'll try to put that in the description box. Folks, want to let you know, whether you be atheist, Christian, you name it, if you have an after show for any of our debates, we are happy to put that in the description box, no matter what side you're on, Christian, atheist, Muslim, you name it. Jake Nelson says, track evolution, you completely missed the point. I think it was T-Rock they meant instead of T-Rack. They say individuals don't evolve. Populations change based on environmental pressures. Get 'em, Ember. Give you
okay.
Respond if you'd like.
I completely missed the point. I never said anything about an individual. However, single cell organisms do constitute a population. In sexually reproducing organisms, either you can have a male and a female, or you can have a fertilized female, usually. So there is no misunderstanding of what the evolutionary model says. I'm well aware that the whole thing is built on populations and populations diverging over time and going separate paths and all of that. That's brilliant, but you're still not addressing the hard science of how that is supposed to take scales to feathers.
You got it.
Tiny changes over long periods of time.
This one coming in from, appreciate your question. Bitter Truth strikes again, says, please explain what is DNA and why there's genetic variations. Creationists have no idea. Wrong. I can explain why the nucleotides are common. So I think first they're saying that the evolution side can explain why nucleotides are common, and also says, please explain though, T-Rock and or Jen, what is DNA and why are there genetic variations?
Go ahead, Jen.
What is DNA and why are there genetic variations? I think it's been established what DNA is already by the scientists. The question is on the level of where did the first organism come from and what were its properties? And there's unfortunately no way to go structurally, in my view, from the parameters of how we currently understand evolution to what we have right now. It doesn't understand the data, doesn't clarify it, and it certainly doesn't, I think it's been made pretty clear tonight that it does not make predictions about the future, as in animals that have not, or life forms that have not existed yet.
Oh,
so
we can
rather than
predict
trying to
more
trick
things
me
will
into
become
answering yes
crabs.
to your question that presumes its own conclusion, maybe think about some of the assumptions going in that it's actually the material, the matter, driving the changes rather than something else, like perhaps electromagnetic field, which
So
can readily be demonstrated.
So the reason there are genetic variations across the globe, and I'm going to use sexual reproduction because it's the one I'm most familiar with, but the human genome, for example, has it has about 3 billion base pairs, right? So if you do the simple math on that, you take 4 to the 3 billionth power, and in a base 10 system, that's something like 10 to the 1.8 billion possible variations on that same quantity. But evolution is bent on the idea that you trace genetic variability through what I'm terming nuclear DNA, which is basically the stable portion of a genome. The nuclear DNA is basically most of the protein coding stuff that tells you whether you're going to have bones, liver, heart, so on and so forth. And so they base their model on the stable portion, but there's a highly unstable portion of the genome as well. And in male and female sexual reproduction, it's for humans, the X and Y chromosome. And those are highly variable. And so they cannot be used in any long distant population studies, because you run into a brick wall going past a few thousand years trying to trace ancestry of humans to any kind of ape form, because our Y chromosomes are so different than chimps and gorillas. So they basically have to ignore that and stick to the part that's highly variable. Now the problem there is that the nuclear DNA, because it is meant to keep a human and a dog and a cat, it has to be stable. If it was not, what would happen is one of two things. Either you would get extremely rapid so-called evolution, or you'd get extremely rapid genetic meltdown. In other words, extinction really quick. So why is there genetic variability in there? It's because the genome has designed variability in the X and Y chromosome and in what's called microsatellites in DNA.
This one coming in from, do appreciate your question. Timothy P. Southwick says, review YouTube Chan's Bravura Media Company, Geography Geek, Wandering. Oh, these are YouTube channels they're recommending. They're saying review these YouTube channels: Bravura Media Company, Geography Geek, Wandering Wolf, and Dean Megalithic Technology. I have no idea what I just recommended to everybody, so hopefully those are appropriate channels. But do want to say a quick housekeeping thing, folks. If you enjoy these debates, consider hitting that share button. Share the joy with somebody else, as that's the completion of, you could say, enjoyment or love, is sharing it with one another. But I want to say, Richard Taylor, last minute question, says, T-Rock, if the ultimate food source was plants that need the sun for photosynthesis, how come the plants were, quote unquote, created before the sun?
Biology 101, you can grow plants in artificial light, right? You don't have to have the sun to grow plants, and light was created on day 1, 3 days in advance of the plants. They had light from the very inception of their creation, and the sun is not strictly necessary for that.
Bitter truth strikes again. Says, T-Rock, your intelligent designer did a bad job designing, and human fixing those by treatment who is intelligent. I got the first part. They say, and human fixing. Man, bitter truth. I'm sorry. The
Pacemaker.
second part,
So like
hard.
pacemakers, we fix the bad design with pacemakers.
I see. They're saying, okay. And humans are fixing those mistakes of the bad designer, they're saying, via treatment, such as what Tom said, in terms of pacemakers or whatever it might be, as humans are intelligent. T-Rock, what are your thoughts?
Yeah, that's a really horrible argument. You're saying bad design means not designed. That's just a huge logical fallacy. But people aren't fixing; they're bandaging temporarily. Nobody wants a pacemaker. They would much rather have the healthy version of the heart. Things are deteriorating. That's genetic and thermal entropy. It's going to happen in this world. And so, yeah, one of the most ridiculous arguments that an evolutionist could make against the creation model is, oh, it's breaking down, therefore it wasn't designed. Yeah, tell that to your Honda in your driveway.
I think it's more God
This one
bad
coming in
designer.
from Bitter.
God bad designer, humans good designer. That's the argument.
Bitter Truth says, each person is unique. DNA carries the instructions for the development, growth, reproduction, and functioning of all life. So again, wrong. I think that was maybe for you, Jen, earlier in terms of how DNA was defined. I don't remember your exact
I
answer,
don't know
though.
if
So
that's
you
a
want to
question,
respond.
but yeah, just keep repeating that and see maybe one day it'll become true.
This one from Justin. Just Justin, no last name, like Cher, says, creationists explain the vestigial feet that are whales that whales have during gestation.
Is that for, can I answer that?
Yes.
I don't see how that would go against my model. It seems to actually support my model because the mind is remembering. It's like, oh, look, I used to have legs. Now I don't. But I still, have that vestigial memory and I had to kind of work through it. I don't know. Thanks for asking.
Embryonic whales do not have minds.
Did you go into the whale to ask them that, TJump?
Yeah, the feet are vestigial prior to when the mind forms in the embryo, so the mind has to come later. It's not like the mind.
Oh yeah, where does the mind come from?
The brain. The brain.
Oh, okay.
In the brain.
And we know
This
that
one
because
coming
of zombies.
from Richard Taylor says, T-Rock, if the ultimate food source was plants that need the sun, oh gosh, I read that already. Bitter Truth says, what is germline or meiosis? Please explain, you guys debating on evolution. T-Rock, you're still wrong.
I didn't get what the actual question was.
They with that loving note at the end about you being wrong. Before that they said, what is germline or meiosis?
I'm not a biologist. I can't give you any technical definition of meiosis that's going to mean anything to you. But what I do know is as I understand it, what germline refers to again is something like nuclear DNA. In other words, it's the common thread that both male and female in sexual reproduction would have, and so that's the whole reason that it's used as the standard for basically extrapolating common ancestry across deep time is because it is highly stable, and the mutations that happen in it, this is kind of a genetic entropy question in a way, because what they're trying to assume here is that this very slow mutation rate in the germline proves evolution, but it doesn't. It's the exact opposite. What's happening is you have a repair mechanism and you have a reproduction mechanism. Neither one of those are part of the extrapolation, but in a thermodynamic system, your efficiency is going to basically give you a prediction about how long a system can last. So for example, in automobiles, they only roughly run around 35% maybe efficiency, and their life expectancy is rather short compared to a lot of biology for that reason. Now compare that to biological systems where ATP synthase is something like 98+% efficient. It's going to last much, much longer. Nevertheless, there is a reproductive system system and a repair system. Those also suffer entropy. They're highly efficient, but they suffer entropy. And what that tells you is the actual entropic principle is based on stacking those in an exponential fashion, as in 98% of 98% of 98% will give you the proper long-term efficiency of the system. And so, yeah, that's germline stable portions of the cell exist to keep you from melting down.
Can I just add one thing quickly there about meiosis? It's the type of cell division in sexually reproducing organisms that reduces the number of chromosomes in gametes. I don't see how that is actually a problem for me. I think the mind could be a perfectly good justification for the choice of which chromosomes are retained and which are rejected. So I think it's the materialists who have a hard time accounting for how that choice was made, because it would appear you need a mind to make a choice.
You got it. Caught in the Middle says, shout out to Modern Day Debate and shout out to TJump for coming on my show. Thanks for the awesome conversation, James. Thank you, and all credit to the guests. They're the lifeblood of the channel. You can find their links below. This one from Theros Rex says, skeptics, our model has predicted many fossilized species in their precise locations and rock layers. In parentheses, they put Archaeopteryx, Australopithecus, Tiktaalik, thank you, say, etc. How do you refute this?
Well, I don't need to refute it. I can just say that's not a prediction, because a prediction is for something that hasn't happened yet, and something that's been dead for a really long time, buried, isn't in the future.
Yeah, I mean, true. For me, it's non-discriminating evidence. The commonality between the evolutionary paradigm and creation is that the fossil record represents somewhat of ecological zonation. So all you need to do to predict Tiktaalik is know which ecological system to look in. If you know that it's a semi-aquatic environment, that's where you go look for Tiktaalik at. If you know it's more or less a tropical land-based environment, then you don't look for Tiktaalik there, because that's not where he would be found. You would look for things like birds and turtles and whatever. So yeah, non-discriminating evidence. It does nothing to distinguish evolution above creation.
This one coming in from, do appreciate it, Theros Rex. We got that one. Jake Nelson. Thank you very much, Jake. Says, Jen, maybe lay off the edibles. Incoherent speech is not a virtue. Just say thank you.
Thanks for the super chat.
This one coming in from Dingley Bumbus says, did T-Rock or T-Jump get their username first? Can either of them back it up with actual proof?
Mine came from an evolutionary process over millions of years. To the TJump name, it was proven by like facts and old time. So I don't know.
Not the leprechauns?
No. This leprechauns are the other ones. Leprechauns did the whole creation thing.
Juicy. This one from Theros Rex says also, James, what is your @ here? I got limited. I think they mean super chats. Oh yeah. It's just Modern Day Debate, the channel name. And Matthew Smelsher says starfish equal no brain organisms. Not saying there's a mind, but it is alive and functioning and making choices. Does this contradict mind equals brain?
I think that's for the evolutionists, isn't it?
That's right. Yeah, I was thinking too.
Wait, what? Starfish do not have a mind. They don't make decisions. They react. There's no consciousness there.
How do you know what starfish think?
Because they don't have a brain.
Well, if they don't have a brain, they don't think much of anything, do they?
How do you know that?
Evidence. Empirical evidence.
Wasn't it Richard Dawkins that said the stuff that rocks dream of? In other words, it's completely intangible. You have no idea of knowing one way or the other.
Oh, sure, it could be completely outside of our understanding and frame of reference. But if that's the case, we have no way of investigating or knowing it. So it's indistinguishable from our perspective of not happening.
You got it. This one coming in from. Do appreciate your question. Bitter Truth says, hilarious how you guys are debating without knowing biology. They didn't say who it was for. I mean, theoretically, it could be for all four of you. I'm kidding. I think I know it's more based off of their previous questions. Jen and T Rock, I assume, based on their last questions that have all been toward you, that they're saying you don't know biology.
I do know biology. Your mom. See, I know biology.
That's true. I have not been
confirmed.
indoctrinated into your cult.
No, I don't know. Bitter Truth, are you satisfied with those answers? We'll go to the next one. They, let's see. Poor Bitter Truth. But wait, let me just log. I think that might be it for quite. No, there's Bitter Truth strikes again. They say, I am asking, did you find Adam and Eve's fossils so you can win? Can you show us?
I got news for you. If you can't find Adam and Eve's fossils, you can't find Luca, you can't find the last common ancestor between chimps and humans, you can't find anything your paradigm claims, except what exists today in today's world.
Our paradigm doesn't claim Adam and Eve's fossils. They, if you could find them, they would be
per the norm. You completely missed the point. It's not about whether you find Adam and Eve's fossils. You can't find Luca. You can't find the last common ancestor between chimps and humans. You can't find any fossil that matters.
Actually, we did. We already found that.
We've already found tons of those. And the question was literally about Adam and Eve's fossils.
This one from Malavia says, a scientific prediction suggests that the data that are consistent with the hypothesis and thus can pertain to future and past experimental outcomes. Direct definition of scientific prediction, Jen. That's what they're saying it is, namely what they just gave.
They want me to give a definition of a scientific prediction, or they're saying
no
that evolution definitely generates scientific.
They're saying that predictions are not about things in the future. You can predict things about the past as long as it's something you don't know yet. So predicting that there's going to be a fossil and finding exactly where it is a scientific prediction. It's not specifically about things that happen in the future.
Well, that's a claim. But I think if you wanted that claim to be true, you'd need to have something specific that wasn't just, well, I'm going to reassert my same flawed line of logic that leads to the idea that there's a slow and gradual change over time, even though that's negated by the fossil record, and just reassert my assumption. I sort of don't see why.
Only there were a way to test these things.
Well, we need to agree on what a prediction is, right? So in my view, a prediction is something that hasn't happened yet. And it wouldn't be called a prediction if you went back in the fossil record and say, oh, look, what we found accords with a model that we understand is right, because it makes all these verifiable predictions and tells us that over time we're going to evolve to maybe finally get our head out of our asses. But yeah, there you go. That's what I mean. The difference. I think if you're looking into the past, to call it a prediction is sort of a bit unclear. You're kind of muddying the waters of science there a bit.
Yeah, no, I agree. That's one of my big complaints about how they extrapolate into the past. You can make up all the stories you want to about the past. Try that exact same methodology in literally predicting the future. It's a failure every single time. But Ember, if you want something testable, so I'm a big proponent of genetic entropy, right? So you want something testable. A good way to test genetic entropy, whether it's actually a problem or not, is to basically accumulate a large amount of data in say human populations where you get the most data about disease and stuff like that, and see if there's a general trend over time of the increase of frequency of breakdowns where things quit working. It's super easy to quote unquote predict, and yeah, you can literally predict the future on this one. The human genome is getting worse over time. 1,000 years from now, whatever time frame you want to put on it, it will be worse then than it is today.
You mean like how the average life expectancy has been going up for decades?
Sorry, that's not a proper root cause analysis. Average life expectancy going up is basically framed in the context of large amounts of diseases like in the 17 and 1800s, before people did silly things like they did in Europe during the 1800s, where they were, I can't remember the name of the city, but basically where the doctors were going into the delivery wards, delivering babies. They were going down into the basement and working on cadavers, and then going back up and working on delivering babies again. They were transmitting germs back and forth. And then you got things like bubonic plague that is basically a disease problem as well. Life expectancies went down during that period. They came back up when people figured out how to wash their hands. So yeah, there's been an increase in life expectancy if you quit doing stupid things that cause diseases and you quit having wars. The genome is so highly efficient that there is no reason, never was a reason, to not live 80, 90, 100 years.
This one coming in from Bitter Truth. You wouldn't believe it. Bitter Truth strikes again. It says religion is just stories, T-Rock. Why should I buy that? Where's the evidence? Give me logic.
The general, I mean, I'll actually entertain that for a minute. He keeps coming back and back like he's just desperate to have the last word. I would recommend you schedule a debate based on pure scientific context, which I don't think you're able to pull that off very successfully. But in order to actually entertain your question, what I will say is that in science, there are two ways to approach things. One's the empirical way, where you collect data and form a hypothesis and do some math and try and figure out what happened. The other way is good old fashioned historical science. Guess which one trumps which? Historical science, where you have eyewitnesses that can verify specific details that you cannot use a mathematical model to discern. And I'll give a real good functional example. Let's say you find a volcano, and in that volcano you do you do a radiometric dating method like potassium argon, and you conclude that, okay, this volcano is 400,000 years old. Okay, find a piece of burnt wood in the lava, do a carbon 14 date on it, and it can't give you anything over about 50,000 years. But go find yourself a letter from a Roman soldier that he wrote to the emperor and said, hey, this volcano popped up in the middle of my field, destroyed my crops, my livestock, send some financial aid. Guess which one of those dates you're going to believe in the secular community? It's the letter, the historical account that told you when it happened. That's the logic behind creation.
This one coming in from, do appreciate it, Malavia, says Jen in all caps, and they sent this twice. That's how much they wanted to be sure you got it. They say, Jen in all caps, I just gave the definition of an effing scientific prediction. How was this hard for you to understand?
Because it's actually more complicated than just predictions. With a model, you have to kind of check that the predictions it makes are exhaustive and accurate. So what you've got is a description that can make sense of what's there, like a language, like English, but English is not true or false any more than French is true or false. So want to bump it up to actually being science, where we're quite certain we can follow it step by step and actually get insight as to what's happening in the process. And I don't feel convinced that state of affairs with regards to modern evolutionary theories quite reached that point. Thanks for asking.
This one from Justin says, creationists, do you know what stochastic processes are? Can you explain why they occur in biology? You can spell just to be sure you want to get the word right.
Stochastic means random.
Huh?
Stochastic means random.
Just to be sure that you heard the word, it's spelled Stochastic.
Is that for me?
Well, they technically say creationists, which makes me think more like T-Rock, but if you want to take a stab at it, I'm sure they're open.
Well, it's
Sure.
Go ahead.
Let me read the dictionary definition real quick. Randomly determined, having a random probability distribution or pattern that may be analyzed statistically but may not be predicted precisely. Why do stochastic processes occur in biology? Is that generally what the question was?
Yes.
Because it's completely random what the biology or what the biota is going to encounter in the world. It's kind of like the evolutionary model of the impact theory for the extinction of the dinosaurs. Completely random what happens in the environment is the real point there. So again, that's a thermodynamics entropy problem. Entropy exists. That's why stochastic processes exist. But the so-called randomness actually obviously does have order. Otherwise, you can't breed generation after generation after generation of fundamentally the exact same life form.
Yeah, stochasticity is not really a thing in my worldview. It's kind of, again, another example of magical thinking where it's like, oh, the evidence doesn't line up with our model. Let's just insert some randomness so that we can have enough vagueness so that it's not totally obvious that this is wrong. So I think if a model has to appeal to randomness or stochasticity, then that is a big red flag, because the model, as much as possible, should be determining the predicted result. That doesn't mean it's pure determinism, because we have stuff like the uncertainty principle to contend with, but that is the flavor of science.
Yeah, and to that point, randomness is actually a very subjective idea. What's random to you may not be random to me, and what's random to you and me may not be random to somebody else. So why does randomness happen? It's basically, how do you want to define randomness?
Well, the atheist will probably take issue with this, but it's a metaphysical assertion that can't possibly be justified by the evidence, because the evidence is going to support dependent arising much sooner than it's going to support randomness, which is in a lot of ways undefinable.
You got it.
It's pretty easy to define. It's a random number. It cannot be predicted.
Undetermined event. That's all it is. Undetermined. Physics, it's a thing. We've proven randomness. It's a fundamental force of nature.
Evolution has to appeal to something fundamentally unpredictable, even though it's a predictive model. Again,
Yep.
It just sort of seems
Reality has indeterminate facts in physics. It is just a thing. We don't get an option. Reality is indeterminate.
You can understand how someone might think that sounded like an excuse.
They can. It's just a fact, though. Like, we tried to make it determinate, we couldn't. It's just a fact that it's indeterminate. Like,
oops, we tried, didn't work. Womp womp. Guess we just have to stick with a shitty model that makes no sense and always has to appeal to taking out parts of the brain. Okay, cool.
Yeah, we have to stick with reality. Reality kind of determines. If reality is indeterminate, we just got to go with reality. That's the way it is.
This one coming in from Jake Nelson says, a prediction is about something unknown. If we predict being able to find evidence in the future about the past, that is a successful prediction. Any thoughts?
Yeah,
I might agree. Go ahead, sorry.
If you want to be technical about it and say, I predict I will find, okay, you're predicting the future that you will find, and then you go and you find, okay. TJump tried to make that point earlier, and it's not invalid. But again, you're talking about comparing one model against the other. You don't have different physical evidence than I do. We've got the same evidence. If we've got the same evidence, we can use very similar inductive reasoning to come to the exact same conclusions, even though our premises are for the entirety of the model are completely different to each other.
And it just kind of sounds like you're conceding that your model can't tell the difference between future and past.
What?
And that would appear to be important, because the future isn't like the past because of something called evolution.
This one coming in from, do appreciate it, Dingley Bumbus says, Jen just gave her thoughts on language, her thoughts on the Tower of Babel in Genesis 11, and its obvious irreconcilable differences from modern linguistics. I think that they think you're a creationist, Jen.
It was kind of hard to follow the meaning of that question. I'm not sure
Well,
if I'm
I
being
mean,
asked to comment on the Tower of Babel.
are you a creationist who believes in the, or I should say, even if you're not a creationist, is there a way in which you believe in the Tower of Babel as described in Genesis 11? Because they seem to think you do. And assuming that you do, correct me if I'm wrong, they say, and it's obvious that this passage has irreconcilable differences from modern linguistics.
I'm
And
not
they
sure that
want,
it has irreconcilable differences, but I don't know enough to really comment on that in particular.
you got it. You guessed it. Bitter Truth says, dude, you had no idea what DNA is, nor meiosis, nor cell division, nor deletion, or insertion, and debated on evolution. Isn't it hilarious? LOL in all caps. T-Rock. T-Rock, I think they're trying to get under your skin.
Armchair warrior. I don't know. I've yet to hear an actual scientific. I mean, he's not even in the debate. The folks that are haven't brought any hard science. They've brought a bunch of philosophical perspectives, but no hard science.
No, I specifically avoided philosophy just for you, T-Rock.
Can you show me your hard science again?
That's my intro. You can rewind the tape afterwards if you want. I'm not going to subject everybody to it again.
Juicy. This one, just let me reload. It looks like we caught up. So I'm going to double check just in case there are any questions in the live chat in addition to the ones that we've read. I do want to say, folks, I have to, if you did not know, I have to say this, you guys, it's going to be absolutely epic. As you can see, my dear friends, at the bottom right of your screen, Mike Jones of Inspiring Philosophy and Daniel Hakikachu will be debating the super controversial question of whether or not minor marriage is acceptable. And by minor, I don't mean like gold miners. I mean like underage people. It is going to be a controversial debate. You don't want to miss it. It's at the conference coming up on Saturday, April 22nd in Fort Worth, Texas. Watch it in person. If you click on the link below in the description box for Eventbrite, you can find those in-person tickets. Otherwise, my dear friends, if you don't have plans for Saturday, April 22nd, you do now. Even if you're from far away, you can watch the whole conference live by throwing just $1 into the crowd fund. That helps us cover the venue and the costs. For example, for TJump to eat during this conference, no joke, we do cover the speaker like Tom's food. I mean, look at him. He's got these unusually large shoulders and he needs food for them. So tremendous shoulders, Tom. Do consider watching live, folks. That's in the description box. But for real, Tom does work out. I know because I've worked out with him. And he was on the elliptical the whole time, like an old lady. No, I'm kidding. That was actually me. But this one from Justin says, T-Rock, do you believe inductive reasoning leads to definitive conclusions? Also, can you explain the difference between an internal and external critique?
Okay, the answer to the first question is yes, it can. If good logic is used during the inductive process and you eliminate unnecessary and unwarranted assumptions, yes, inductive reasoning can lead to firm conclusions. What's the second part of the question? Can I explain the difference between internal and external critique? So in an internal critique, which is what you really want to do, is you want to take the worldview and test it against itself, completely eliminating all of the competing views. So it's completely internal. So you test its logic against itself. External critique is where you compare one model to another and basically see if you can delineate significant differences between them.
You got it.
Just a question. I thought we were all going to eat Subway at the event. We could just show them your tattoo on your back. Just everyone gets Subway. Isn't that how it works?
2 meals will be part Subway because at the conference, folks, we do have, if you sign up for the VIP, you can have food, lunch, and dinner with the speakers. And part of that is Subway. But we also get pizza because, you know, you don't always need to be healthy. You can have some pizza too. I love pizza. But anyway, this one coming in from Justin says, T-Rock, do you believe? Oh, we got that. Sorry. Okay, that's embarrassing. Says, Timothy P. Southway says, why don't you all lying, cowering cowards first come clean and fess up, you deceivers? God bless you all that are telling true as able and such, my friends. What does that mean? I don't even know what that means.
Oh, bless you too, Tim.
Let's see.
I think they just wanted to tell us how much they love us by threatening us all with eternal hellfire.
Makes
They
perfect
didn't
sense.
quite mention hellfire. They just said, you lying, cowering cowards. And fess up, you deceivers. I don't know. But I thought,
I'll admit it.
but I'm confused.
I'm a liar.
Whatever.
The truth is that I am James's father. I've been lying this whole time. We're actually related. Me and James, family.
It's true. And T-Rock is T-Jump's dad and my grandfather. But my dear friends, Jen's clearly adopted. But want to say we love all of our guests, including my brother, Ember. And yes, we do appreciate all of our guests. So seriously, it has been a truly fun time tonight. I enjoy this. I told the speakers before I started that I just enjoy this so much. It puts an extra spring in my step. So I want to say thank you for you hanging out there in the live chat we see there. I'm going to put a poll in terms of who you thought was most persuasive. So feel free to vote on that poll. I'm going to be back in just about 60 seconds with a quick update on this upcoming conference, folks. You don't want to miss it. So stick around, and want to say a huge thank you to Jen, T-Rock, TJump, and Ember. It's been a true pleasure to have you here tonight.
Thank you, James.
Thanks, James.
Appreciate it.
Thank you,
My
thank you.
pleasure.